Something is stirring beneath the Bay of Naples right now, and the sea itself is trying to warn us. Bubbles are breaking through the calm surface in frantic bursts, rising from the depths like desperate signals from a world we cannot see. Scientists have been watching this region for decades. They have prepared for many scenarios. But what they are witnessing now matches the exact warning signs they feared most, and they believe the sea is bubbling for a reason that could change everything. This is not speculation. This is not exaggeration. This is what is happening right now beneath one of the most densely populated volcanic regions on Earth. And by the time you finish watching this, you will understand why researchers are working around the clock, why emergency plans are being quietly updated, and why the next few months could determine the fate of millions. Let me take you beneath the surface. Let me show you what the world is only beginning to understand. It started with something that seemed harmless. Scattered patches of bubbles rising through the otherwise calm bay. The water here has always been warm. The region sits atop an ancient volcanic system that has shaped the landscape for thousands of years. But these bubbles were different. They were not random. They were not gentle. They formed in tight clusters, appearing suddenly and disappearing within minutes. Local fishermen were the first to notice. These are men who have spent their entire lives on this water. They know every shade of blue. They know how the currents move. They know when something is wrong. And they knew immediately that something was very wrong. The water around these bubbling patches shifted from clear blue to a cloudy green. Then it darkened, as sediments stirred upward from the depths below. Some boats reported faint vibrations. Not waves, not wind. A soft rumbling coming from the seabed itself, like an engine idling far beneath the surface, like something waking up. At first, local authorities dismissed the reports. They called it seasonal gas release. They called it biological activity. They said there was nothing to worry about. But marine technicians were already taking measurements, and those measurements told a very different story. Carbon dioxide levels had spiked far above normal. Sulfur-rich gases were pouring out of newly opened vents at rates that alarmed even veteran researchers. Temperature probes detected warming along the seafloor. Not dramatic warming, subtle warming, consistent warming. The kind of warming that suggests something much larger is happening deep below. These were not surface disturbances. These were the earliest symptoms of pressure building beneath Naples. Pressure that has been growing for years. Pressure that may soon demand release. To understand what is happening now, you need to understand what lies beneath this region. The Bay of Naples sits within the Campi Flegrei caldera. In Italian, the name means burning fields, and for good reason. This is one of the largest volcanic systems in Europe. It is not a single mountain like Vesuvius. It is an entire landscape shaped by fire. The caldera stretches across roughly 13 kilometers. Within its boundaries lie the city of Pozzuoli, parts of Naples, and dozens of smaller towns and villages. Nearly 500,000 people live directly on top of this system. Millions more live within its potential impact zone. Beneath all of this lies a massive magma chamber, a reservoir of molten rock that has been monitored for decades. For most of that time, the system remained relatively quiet. There was activity, yes. There were earthquakes. There was slow ground movement. But nothing suggested an imminent threat. That is changing. GPS stations across Pozzuoli and parts of Naples began recording a pattern that scientists had hoped they would never see again. Rapid, synchronized ground uplift. The land itself was rising. For months, the movement had been slow, almost gentle. Scientists call this phenomenon bradyseism. It is a gradual rising and falling of the ground caused by the movement of fluids and gases beneath the surface. The region has experienced this for centuries. It is part of life here. But then the pattern changed. The uplift accelerated. Entire neighborhoods shifted upward by measurable centimeters in just a few weeks. Not over months, not over years. Weeks. Residents began noticing small but unmistakable changes. Doors no longer closed properly. Windows jammed in their frames. Sidewalks developed fresh fractures. Pavements tilted slightly toward the sea. Civil engineers conducted inspections and found subtle deformations spreading across older structures. In some areas, drainage systems reversed flow as the terrain shifted beneath them. Even the shoreline began to change. Rocks and ancient steps that had been underwater for generations were suddenly exposed. The land was warping beneath people's feet. If you are finding this information valuable, take a moment to hit that subscribe button and turn on notifications. This channel brings you important stories from around the world, and your support helps us continue this work. Now, let me explain why this uplift is so significant. The movement is not random. Satellite interferometry revealed a broad dome forming directly beneath the most active part of the Campiflegrei system. Something underground is expanding. It could be gas. It could be magma. Most likely, it is both. And it is pushing the entire region upward like a slow, powerful breath. Scientists describe living in this region as living not just on a volcano, but inside a volcano. The caldera itself is the remnant of massive eruptions that occurred tens of thousands of years ago. The people of Naples and Pozzuoli have built their homes, their schools, and their businesses within the crater of an ancient supervolcano. As the uplift continued, gas monitoring stations across Campiflegrei lit up with readings that alarmed the scientific community. Overnight, concentrations of carbon dioxide shot far above baseline levels. But it was another measurement that truly captured attention: helium-3. This is a rare isotope. It does not come from normal geological processes. It rises only when magma approaches the surface. And helium-3 levels spiked sharply. At the same time, sulfur dioxide surged. This is a classic indicator of superheated fluids forcing their way through fractures in the crust. These gases were not drifting out slowly. They were venting with force. Rising through cracks beneath Pozzuoli, rising through the famous Solfatara crater, rising through the floor of the Bay of Naples itself. Thermal cameras captured glowing plumes of vapor in locations where there had been no visible activity just days earlier. Some vents emitted gas so concentrated that nearby vegetation turned yellow and brittle within hours. Plants that had grown in the same spots for years died almost overnight. Researchers compared the chemical signatures with historical data. They found an unmistakable pattern. The gas composition matched conditions recorded before the 1538 eruption of Monte Nuovo. That eruption was the most recent volcanic event in the Campiflegrei system. It created an entirely new mountain in the span of just 1 week. The current readings were even stronger than those historical records. Emergency teams installed portable monitors around schools, ports, and residential blocks. The concern was not just rising gas levels, it was the rate of acceleration. The speed at which everything was changing. Thermal drone flights over the Bay of Naples revealed something that immediately escalated the situation. Broad patches of the seafloor were warming rapidly. At first, the bright infrared signatures were limited to a small cluster near Pozzuoli. Within days, the hot zone widened into a sprawling network of glowing streaks beneath the waves. Underwater sensors confirmed the change. Temperatures had risen several degrees in a matter of weeks. This was far too fast to be explained by normal geothermal activity. The ocean above the vents shimmered like water in a pot being gently heated. Microvents multiplied. Constant streams of gas made the sea appear to simmer. Some stretches produced enough bubbles to push small fishing boats sideways. Marine biologists documented fish fleeing the area in large numbers. Divers reported visibility distorted by rising thermal plumes. The underwater landscape was transforming. These were not isolated hotspots. The pattern pointed toward a massive body of pressurized heat moving beneath the crust. It was creeping upward. It was releasing energy through every weakness available. And researchers warned that if the heat front continued expanding, it could destabilize the seabed itself. This matters because underwater volcanic systems behave differently from land-based volcanoes. The presence of water changes everything. When superheated materials meet seawater, the result can be explosive. A sudden release of pressure beneath the bay could trigger what scientists call a hydrothermal explosion, a violent burst of steam, ash, and debris that erupts from below the waterline. Such an event would not give much warning. Models show that even a modest hydrothermal burst could send waves slamming into the nearest shoreline within minutes. Scalding water, shattered sediment, debris raining across ports, beaches, and densely packed neighborhoods. The danger is not the scale of the explosion, it is the speed and proximity. Fishing boats, ferries, and waterfront homes sit directly above unstable ground. The impact window would be brutally short. As gas emissions and seafloor heating intensified, the ground responded with a new and unsettling rhythm. Clusters of shallow earthquakes began striking Naples, Pozzuoli, and surrounding towns. Sometimes dozens occurred within a single hour. These were not deep tectonic quakes. They were happening just a few hundred meters below the surface. This is the exact depth where pressurized magma and superheated fluids force rock to crack. It is the depth where the crust breaks under internal pressure. Residents reported windows rattling repeatedly through the night. Shop owners found fresh fractures running across their walls each morning. The shaking was constant, relentless, a reminder that something beneath them was moving. Seismologists reviewing the waveforms noticed a troubling progression. The quakes were becoming shallower, they were becoming sharper, and they were migrating toward the area directly above the most active gas fields. This was not random shaking. This was the crust deforming. This was rock fracturing under rising pressure. This was a system tightening like a clenched fist. More than 135 seismic events were recorded in just 1 week. Some were small, some were large enough to wake people from sleep. All of them pointed in the same direction. Upward pressure, building force, a system preparing for something. The last time Campifligure produced this pattern, an eruption followed within days. Civil protection officials quietly raised monitoring levels. Teams were dispatched to inspect schools, bridges, and hospitals for structural stress. Every tremor signaled the same message. The system below was approaching a threshold. High-resolution radar and GPS data delivered the most alarming discovery yet. The deep magma chamber beneath Campifligure was expanding. At first slowly, then with measurable acceleration. Instruments showed that molten rock was melting its way upward. It was softening the crust above. It was creating new pathways for gas and heat to rise. This was not the long, stable chamber that scientists had monitored for decades. Its internal pressure had shifted. New magma was being injected from even deeper within the Earth. As the reservoir pushed upward, models indicated increasing stress on the brittle rock layers above. These layers had already weakened through years of uplift and seismic activity. Now they were being tested again, pushed from below, cracked from within. Geophysicists compared current readings to historical records. They found disturbing similarities to the buildup before past explosive phases, including the 1538 Monte Nuovo eruption. But this time, the affected area was far larger. The pressure was distributed across a wider zone. The potential impact was greater. Pressure simulations warned that the chamber was approaching a threshold, a point where even minor shifts could trigger cascading failures in the crust. Small changes in temperature, small changes in pressure, small changes in the flow of fluids. Any of these could push the system across a line that cannot be uncrossed. Researchers describe the situation with careful but serious language. They spoke of a system entering a phase that had not been seen in generations, a phase that ended, the last time it occurred, with the birth of a new volcano. Let me tell you about Monte Nuovo. In 1538, over the course of just 1 week, a new mountain rose from the ground near Pozzuoli. Before the eruption, the area experienced many of the same signs being observed today: ground uplift, earthquakes, gas emissions, changes in the shoreline, bubbling in the water. The eruption itself was explosive. It killed people. It destroyed homes. It reshaped the landscape permanently. The mountain that formed still stands today as a reminder of what this system can do. Researchers are now cross-referencing modern readings with accounts from the months leading up to that event. What unsettles them is not any single anomaly, it is the sequence. A sequence repeating itself with unnerving precision. Gas emissions are climbing along the same coastal arcs where Renaissance fishermen once reported burning breaths rising from the sea. Shorelines are shifting in patterns that match the documented changes observed weeks before the 1538 eruption. The rate of uplift shows a familiar rhythm, slow pulses followed by abrupt accelerations, identical to measurements inferred from old damage records and land deformation sketches preserved in historical archives. Each new dataset strengthens the parallel. Each measurement pushes scientists closer to a conclusion they once considered distant. The Campi Flegrei system may be entering a phase comparable to the one that produced Italy's most recent volcanic newborn. The echoes of history are not distant. They are aligning in real time. As scientific reports circulated through government channels, Italy's Civil Protection Agency escalated its posture without public fanfare. Internal bulletins upgraded alert levels. Regional offices were instructed to refresh evacuation models that had not been updated in years. Sirens in coastal towns underwent unannounced tests. Their sudden wails caught residents off guard. In schools, teachers quietly rehearsed exit procedures. They framed them as routine preparedness rather than emergency planning. But the timing was not lost on observant parents. Street-level notices began appearing on community boards, new assembly points, adjusted hazard zones, revised traffic flow maps designed for potential mass departures. The government was not making dramatic announcements, but it was preparing for something. Locals who have spent their lives on the caldera feel the tension rising beneath the official calm. Conversations in cafes revolve around subtle but unmistakable changes. More patrol cars near monitoring stations, more helicopters scanning the fumarole fields, more late-night meetings in municipal buildings with no explanations offered. The scientific community is watching every signal. Ground uplift continues in irregular surges. Gas levels spike beyond historical baselines. Seismic swarms cluster around fault lines known for enabling rapid pressure transfer. Patches of seawater and crater floor pools are heating to levels that indicate boiling just meters below the surface. Individually, none of these signs guarantee an eruption. Volcanic systems can show activity for years, even decades, without producing a major event. The Earth operates on timescales that do not match human expectations. What looks like imminent danger can stabilize. What looks calm can suddenly erupt. But combined, these signals form the exact convergence that researchers have long feared. A fragile crust suffering stress from multiple directions. A system vulnerable to even slight changes. The danger is not necessarily a dramatic trigger. It is the possibility of a subtle shift that pushes everything across a threshold. For scientists tracking every tremor and every bubble, the margin between stability and escalation is narrowing. The data does not lie. The patterns are clear. Something significant is happening beneath the Bay of Naples. Nearly 500,000 people live directly within the caldera boundaries. Millions more live in the greater Naples metropolitan area. This is one of the most densely populated volcanic regions on the planet. If a major eruption occurs, the impact would extend far beyond Italy. Ash clouds could affect air travel across Europe. Economic disruptions would ripple across the continent. The human toll could be devastating. Scientists are careful not to cause unnecessary panic. They know that predictions are uncertain. They know that volcanic systems are complex. But they also know that preparation saves lives. And they are urging authorities to take every precaution. Emergency services are on heightened alert. Hospitals are reviewing surge capacity. Transportation agencies are studying evacuation routes. The machinery of disaster response is quietly humming in the background, waiting to see if it will be needed. And still the bubbles rise. Still the ground swells. Still the earthquakes ripple beneath sleeping neighborhoods. The sea off Naples continues to simmer, sending its warnings to anyone willing to watch. History has shown us what this system is capable of. The Campi Flegrei caldera has produced some of the largest volcanic eruptions in European history. 39,000 years ago, a super eruption here ejected hundreds of cubic kilometers of material. It affected climates across the globe. It may have contributed to the decline of Neanderthal populations across the continent. That scale of eruption is not what scientists expect now. But even a smaller event, comparable to Monte Nuovo, would have serious consequences for the region. And the warning signs suggest that something is building, something is moving, something is preparing to happen. The question is not whether Campi Flegrei will erupt again. Scientists agree that it will, eventually. Volcanic systems do not simply turn off. They operate on cycles that span centuries and millennia. The question is when. And the question is whether we will be ready. Right now, the world is watching. Researchers from across Europe and beyond are contributing data and analysis. International monitoring networks are focused on this region. Every possible resource is being directed toward understanding what is happening beneath the Bay of Naples. If you have watched this far, you understand why this matters. You understand why millions of people are living with uncertainty. You understand why every bubble rising through the water carries a weight far beyond its size. What happens next remains unknown. The Earth keeps its own timeline. It does not answer to human schedules or human concerns. It simply moves according to forces we are still learning to understand. But one thing is certain. The Bay of Naples is trying to tell us something. The question is whether we are listening carefully enough, whether we are preparing quickly enough, whether we truly understand what is at stake. Share your thoughts in the comments below. What do you think should be done to protect the people living in this region? And if this story has made you think differently about the power beneath our feet, consider subscribing to this channel for more important updates from around the world. Beneath the calm surface of the sea, beneath the ancient streets of Naples, beneath the homes where families sleep tonight, something vast and patient is stirring. It has stirred before. It will stir again. And when it finally moves, the world will remember that we were warned. The only question that remains is this: when the Earth speaks, will we be ready to answer?